Graph interpretation word problems. Efficiency of a motor can be measured by the percentage of the input power that the motor uses. EC models efficiency in percentage points of a certain motor as a function of the power input's current C, that's in amps. Match each statement with the feature of the graph that most closely corresponds to it. So if we have an x-intercept, the x-intercept is where it touches the x-axis. We know that the x-axis is a domain, and the domain is you can drive. So the domain you can drive. It's like the bus driving. So this is our x-axis. We have contact at 3. We have contact in front of 0.5. So the motor loses all efficiency when the current hits 3 amps. That is true because that touches the X. That is the end of it. So it starts right below, right in front of 0.5, and it stops at 3. So all efficiency with the current hits at 3 amps. So that means it basically turns off. So that's fine. Now the relative maximum, as the input power grows beyond 1 amp, the motor becomes less efficient. At its most efficient, the motor uses about 50% of its input power. So when you're doing relative maximum or minimum, you want to know, what is a height? Because remember, it's not the absolute maximum or minimum, but you want to look for some of the highest points and some of the lowest points there. So if we look at this 50 here, the 50 is at the highest point. So that would actually be a maximum there. Now the increasing and decrease of intervals is sections that go up if it's a positive, that's an increase, or it goes down if it's a decrease. So if we look at 1 is right here, and we look at the graph and we run it to the end, you can see that it's going downward. So since it goes downward, that is a negative. So as the input power grows beyond, that means it goes past 1, the motor does become less efficient because you can see that it works less and less and less. So the power to it is beginning to diminish. So let's check this. Okay, let's move on to the next question. Vera made a rectangle using a string that's 40 centimeters long. Okay, a function a, w models the area of the rectangle in square centimeters as a function of a rectangle's width in centimeters. Match each statements with the figure of the graph that most closely corresponds to it. So you have what's known as a bell-shaped graph because it goes up, at an even pace, and it comes down as an even pace. And you can see it starts at 0. If you look at the graph, a couple things we can get out of this. It starts at 0, it ends at 20. The highest point of it is right here at 100. So that's some of the shapes we can take a look at and see. So it says the greatest possible area of it is 100. It says when the width of the rectangle is 20, there's no centimeters, as the width of the rectangle is extended towards 10 centimeters. So notice the number 20 was mentioned, and we want to do the x-intercept. Remember the x-intercept, that's the x-axis, that is your domain, you can drive on it. So we start at 0 and we end at 20. So there's that number 20 being mentioned here. So that's going to be my x-intercept, so I can slide that panel there. Now I want the relative maximum or minimum. Okay, the highest point we saw from the graph was at 100. So the greatest possible area of the rectangle is 100. So that is the height. Now the next part is the increase or decrease. It says the width of the rectangle extends towards 10 centimeters as the area grows. So what we do is we look here, we use this 10 here, we follow it all the way up, and you see there is an increase here. So it's going up, 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 kind of like a roller coaster. Then you reach the highest point, then it goes down. So this right here, should be the correct answer, because we have the 20 for the x-intercept. The highest point is at 100. That's our a maximum. And then our decrease increase, well, if you go look at the 10, because the number is talking about the 10, and the 10 cuts it in half, so we definitely see the increasing, and then we see the decreasing. Okay, next one. Saban opened a new martial arts gym. The function NT models the net worth of the gym in thousands of dollars after T months. So remember, the letter T in there is time. This is based on your months. And what the function is talking about, this N is his net worth. And the net worth is how valuable your business is. So we look at our graph, we see a couple things. We see it starts at 4 here. We see it's ending here, and this would be like at 14, or we're actually, what I mean by ending, we're basically seeing where it ends, where it starts on the graph, and where it goes off the graph, because you were only looking at a section of it. This thing could be expanded to as much as the graph as you want, but we're just seeing like a small part of it. We also see it touches the x-axis at 2, it touches the x-axis at 10. And then as for a lowness here, it actually drops below -3. So, we would be talking here at -3.5. So that would be the lowness of it. So let me redo these here so I don't cover up the numbers. So we have a contact here at 2. And we have a contact here at 10. So this was my x-axis there, and this is my y-axis. Because the x-axis, you can drive on it like the bus. The y-axis goes up or down like the rocket there. So let's see what some of the questions it's asking. Okay, it's not talking about any of the x and y intercepts. So let's talk about the gym was losing money for the first 6 months. Okay, so the gym was losing money for the first 6 months. The gym's losses exceeded its profits between 2 and 10. It says the gym's net worth was at its lowest after 6 months. So here are 6 months here. And if you follow this all the way down, this is like the upside down bell-shaped curve. So it did go to its lowest point after 6 months. Since we're talking about a certain point there, that would be your relative maximum. So this is where it should be here. Actually not. This should be there, because it says the gym's net worth was at its lowest points after 6 months. Now we want to know about a positive or negative interval. So when you're talking about the interval, be it positive or negative, the whole thing has got to be in a section, like the whole thing is positive or the whole thing is negative. So what I mean to talk about positive and negative, again, using the x-axis here. So if we use the x-axis as our mark, the positive interval would be anything above this. The negative interval would be anything below it, but the whole thing has got to be there. So let's look at from 2 to 10. If you look at from 2 to 10, if you run this from 2 to 10, the entire interval where it starts from 2 to 10, the entire thing is negative. It's in the negative. So right there, that would actually be a negative interval, because when you do positive or negative intervals, the whole section's got to be all in the positive or all in the negative. So when you look at from 2 to 10, the whole thing is in the negatives. Now it says it's increasing. The gym was the gym was losing money for the first 6 months. So these are the timeline. So this is the first month, this is the second month, third month, 4th month, 5th month, and 6 months. So if we start here, when they first opened up, they were losing money. So the first month they lost money. Second month it's still going down. Third month it's still going down. 4th month it's still going down. So that would be a decrease in intervals. Now a decrease in interval is it can be a mixture. Notice above this line here was our positive, below the line was a negative. So when you're doing an increase or decrease in interval, you look at the whole thing. So it starts here, it ended up here, that the whole thing was going down. And even though part of it sat with the positive, part of it sat with the negative. Now, if you're just doing positive or negative intervals, the whole section's got to be positive to be, the whole thing's got to be above the x, or to be positive, or negative, the whole section's got to be below the x to be negative. So that's the difference between those two, because they sound like they could be almost the same, but they're not. Remember, positive and negative intervals, the whole thing's got to be there for the positive. The whole thing's got to be there for the negative. The increasing or decreasing, well, it doesn't matter, you know, if you're above the x or below the x. You look at it from where it starts. You start at 4 and you end up right there. You end up right there. So if I did use a different color here, I'd start here and I end there, and you can see this whole thing going down. So let's go and check this. Okay, let's go to the next question. Okay, Keith is an elevator operator in a big hotel. Okay, A is the altitude and T is the time that's in minutes. So A is the altitude and T is the time in minutes. Match each statements with the features of the graph mostly corresponding to it. So if we look at the graph before we actually get into it, we see we start at 8 and we end at 10. That's what the graph is showing us. Now, again, this could be just section of a bigger graph, but from what we notice, we start at 8 and we end at 10. We see that it goes as low as a -12. Now, right here, it looks like it went across. It was right on the x-axis. So it looks like it's going straight across there from 3 to 3.5, and then it begins to drop. But basically, you go up, then it goes across. You go down, then it goes across. It drops all the way down, and then the highest point, let's take a look at the highest point. The highest point of this graph is at 20. So 20 is my highest right there. So let's see if we can, go ahead and look at some of the questions here and see if we can figure out how to move the panels to make this correct. Okay, if we look at our possibilities here, we do not have any x or y intercepts. So let's take a look at this. The 12. Now, when you do a relative maximum or minimum, we want to know what the low point is and what the high point is. Well, we recognize that the high point was at 20 and the low point was at -12. Notice it says Keith's altitude was 12 meters below the ground. Now, this right here, if we draw this as x here, if we call this x and we have our line across, anything above that is positive, anything below this is negative. But see, this, if we consider it like ground, the x would be called the ground level. So you can be above ground level, so that would put you on a hill or a mountain, or you could be below. If you were in a hole or land that was below this level, that would be considered to be negative. So anything below, ground zero, because they call this ground zero, here is called ground zero. Anything above it, those would be like, hills or mountains, things that are giving you height. Anything below this, below it, but actually puts you into the negative range. So when it said that Keith's lowest altitude was 12 meters below the ground is the same thing as saying -12. So we'll move that panel up to relative maximum or minimum. Now we want to talk about the positive or negative intervals. Like I told you before, if it's positive, it's all got to be in the positive. If it's negative, wherever you start, wherever you end's got to be into negatives. You can't mix it. You can't be in both. The whole thing's got to sit in the positive, or the whole thing's got to sit in the negative. So we got two choices here. We got 5 to 8. If you notice 5 to 8, that one is down here at the negative and one is there at the positive. Now the other choice we got is 6.5 to 10. Notice 6.5 is right here. So this is where it starts. It starts right there at 6.5, right here. It goes all the way up, it comes all the way down, and it stops right there. So the entire interval is in the positive. So it starts at 6.5, it goes in 10, so the entire interval sits in the positive. So that would be considered a positive interval. Now the 5 to 8. Well, 5 is here, so this is my 5. My 8 is there. Now if you look at this interval, and I tell you, well, let's try again a different color here. My interval will start here, and then I'm going to work my way up. Look at that. So the whole thing is going in upward motion. Now with the increase or decrease interval, you are allowed to go from negatives to positive. You're allowed to mix those together. It's just the positive and negative intervals you cannot do that. It's either the whole thing's positive or the whole thing is negative. So I believe the way those panels sit, that one should be correct. So this should be our correct answer.